Okay. I'm Ting. I'm a student of Brain and Cognitive Sciences, and I'm affiliated with the Human Language Processing Lab, which is under the director of Dr. Florian Jaeger, who is currently in Mexico doing a field study. But he'll be watching my presentation through the video that Katrina is recording right now. And I thank my father for some intensive discussion on Chinese and the Chinese literature, something like that. He's more knowledgeable than I am, and he'll be watching my presentation through that one. So thank you. And my friends who have voluntarily given me their Chinglish essays, which is also part of my research to analyze the information distribution in Chinese English. So finally, people at HLP Lab, they watched me doing a practice run yesterday and gave very good comments and advice. So I begin with my presentation with a little question for all of you guys. Could you spend like 20 seconds reading all the 3 sentences and reorder them? They are in a jumbled up paragraph. Okay, time is up. And do you have any idea which one is first and then which one is second and which is the last?
3, 2, 1.
Yep. No, actually 3, 1, 2. So, but actually now if you read this, you would somehow think, yeah, that's probably the right sequence how a sentence should be organized. And it's an amazing ability that we humans are sort of naturally able to do that. We not only in spoken language. When I am the speaker, I speak those sentences in the right order so that you can understand me better. And when I'm the writer, I write in the same way. And if you are a listener, you sort of expect that the speaker will say the things in that order, so you can have a better time understanding what he or she is trying to say. So if humans try to communicate in the most efficient way, they should produce language by putting less information into sentences with less prior context and more into later sentences. So as you go along further into the discourse, then you will have more context that have been built up into the entire one. And the purpose of doing so is to ensure the increase of information is uniform. You wouldn't have something that is too easy or something that is too hard in the entire discourse. Is everybody following this? So this is the fundamental idea, so I want to make sure everybody understands this. That's how people formulate this theory. It's called uniform information density. So this is actually a toy graph. It's not real from any real data. It's fictitious. So the x-axis is the sentence number within the document, and the y-axis is how we measure information. I will talk about that a little bit more later. So you would expect the information will be uniform in the discourse from the first sentence to the end of it. Okay? It's more. Well, if you, for those of you who are interested, it's actually well-founded on the engineering perspective. In 1948, Shannon proposed an information theory which says the most efficient way of sending information is to send this at a constant rate. So people will sort of build the expectation of what you're going to convey later and later on. Okay? But in language study, there are no good models of information. So we cannot sort of estimate the context of the sentences easily. We humans can do this because we have memory. We can analyze what we said before. But to let a computer know that, it's a bit inaccurate. And natural language processing, which is a computational study of language, it provides some method for estimating the out of context information. Can you see this in red? Yeah, it's in red. So out of context information means we are literally looking at a sentence in isolation. We do not compute the previous context information for the sentence before and we only look at them one by one, even they are in the same paragraph or in the same document. Okay. So if we revise the prediction a little bit to use what I have talked about a little earlier, then less contextual information is available at the beginning of the discourse. So if speakers, writers want to communicate efficiently, early sentences should be made more predictable. So it will be easier for listeners. As a result, the out-of-context information at the beginning of the discourse should be lower than those in later of the discourse. Okay? And we should expect something like this. In the whole document, the information will gradually increase with the increase of sentence number. Okay? Did I lose anybody? Okay, cool. And the first evidence actually came up in fairly recently. It's in 2002, so only 6 years from now. Genzo and Shinek in Boston University provided the first evidence for the hypothesis of uniform information density. And they analyzed an English corpus, which is a collection of, and they found that the information of sentences did increase with sentence numbers in a discourse. And the effect of this increase is due to both lexical and non-lexical factors. Like lexical factors means which words you choose to use. Maybe at the at very beginning of the discourse, you use more predictable words like I, it, like the, those words people are getting really used to. And at the later stages of a discourse, you will use words like esoteric words, so like big words. And it also depends on how words are used. People may add different grammatical structures, more complicated grammatical structures into the discourse as they talk. So the current work, I spent a lot of time talking about that. I just want to make sure you understand what I'm gonna do. We have evaluated the uniform information distribution, the theory on Chinese written corpora by measuring information content. And we did the same thing on the Chinese English corpus, which I collected by myself. And ultimately, the purpose of this research is to see why is Chinese English harder to understand for native English speakers, while it is relatively easy for Chinese speakers. Well, does Chinese have a different information distribution than English, or it should be the same, but somehow it is grammatical mistakes or the choice of words that have caused the Chinglish harder to understand. So we want to know more about this guy. The first study, we used four different corpora. The first one is Beijing and the Taiwan and the Hong Kong, but that one has too little data, so I drop it. And the fourth one is the Voice of America Chinese News. And we built an N-gram language model to measure the information in the written Chinese sentences. The N-gram model is actually a very straightforward idea. So gram means like a sequence of words. Okay, so this is a Chinese sentence. I read it once. 20年前，许多中国家庭的梦想是拥有一部电话. I read it word by word, but in reality, I wouldn't do this. And so this is a translation for that. 20 years ago, many Chinese family dream is to have a piece of telephone. I dropped all the morphology changes. So the trigram, in the trigram model, we take every 3 consecutive words to build a database. So we would have 20 year ago, comma, ago, comma, many, Chinese. So on and so forth. So we would have a very large database which contains these trigrams. And each one, to calculate the probability for the entire sentence, we multiply the different probability values of different trigrams. Okay, so then we take the negative log of the entire probability value, which yields the information content. But you don't have to understand the details of this. It's rather complicated. And in practice, we use this lexicalized part of speech anagram, which have words in them, but also have the part of speech text in them. So the first one will be labeled as a cardinal number, and the second one is measure word, and the third one is a locator, punctuation, so on, so on. So this, by doing so, I hope to capture some of the syntactic, so which words, what kind of roles that do the words play, the syntactic information in that. We investigated two effects. The first, two kinds of effects. The first kind I call it global effects. So it is considered with respect to the entire document. We look at the sentence effect in the document and the paragraph in the document. This is a graph. And as I said earlier, we are hoping to see an increased line in general that will go with the increase of the sentence number. But in this graph, we actually do not observe an obvious increase in this one. But in the Voice of America corpus, you can sort of see there's an increase. But in the two really native Chinese corpora, we do not see such an increase. It's almost already uniform, or even it's measured without a context. And the paragraph effect came out better than especially like for the first 5 paragraphs, you can see a sort of very clear increase in that. So this means, like, as we are going on into the discourse, later paragraphs contain more information than beginning paragraphs. Okay. And we also investigated the local effects. The local effect is to investigate the how information content will change with respect to a linguistic unit, and we restricted the domain into its immediate containing linguistic domain. So it's a rather complicated way of saying this. So we are measuring sentence position, the effect of sentence position within a paragraph, not within the whole document. And we do this to measure the effect of paragraph in the document, because document is the container of the paragraph. And we are the first one to do this. We measure the word position in the sentence domain. We do not look over beyond the sentence domain. We did a multiple regression on the above 3 predictors. First, we are very glad to see this graph. This is a contour map. Imagine like you see the contours of height on the real map. So this means, like, with the increase of a paragraph position, we actually see a sort of diagonal increase, that the increase of the information content. And also on the y-axis, we see the information content increases with sentence position within paragraph. Okay, so these two are significant. And in this amazing graph, that even within a sentence, the information each word carries also increases within with respect to the position. But in this one, we actually have a limited amount of context information available. Why? Because we use this trigram model. This trigram model can capture some of the information within the sentence, because when we want to measure the information content of the word, say Chinese, so we are actually taking into the context information of the comma and the many. Okay, so because of this, we sort of seen an early convergence that occurs at the 10th word. This is actually very interesting, because we predicted that if we measure the information content of a linguistic unit within context, then the information will be uniform. This is very preliminary, but we guess this might have something to do with the underlying theory. So in summary, we have replicated against our Nishaniak studies on Chinese corpora. We did not find any sentence effect within documents, but we do find those local effects, that paragraph effect is significant within document, and the sentence information content also increases within the paragraph. But due to the size of data, we used a relatively small corpus, and Chinese corpora aren't very large in general. The effects are observable only very early in discourse. So technically, this means the cutoff values are very low. And I'm proud to say we are the first to look at the effect of word position within sentences, that information content increases with word position. And I have explained that this is probably due to the limited amount of context information. So does increase of information only occur locally in Chinese? The current data seem to support this idea. Actually, we have not found a global increase on the sentence effect within the document. So how much time do I have? Right, so this is a problem, probably of the writing style. So in Chinese, we usually write in the way that goes sort of, we summarize what we are gonna write, and we are gradually talking about the detail points of that summary. So we present the most informative idea at the beginning of a passage, and we sort of expand what we are gonna write. What are the details that could be supportive to my idea. And in English, especially newspaper articles, I read through some of them, and I found most of them are in the narrative style. They talk things like telling you a story, not really expressing any personal conclusions or ideas on the matter. And that is probably the factor that has driven the differences between Chinese and English. I will go very quickly through this, and this is very preliminary. And in Chinese English, actually, we see the information value is very high. You can see the y-axis actually says 8.1, 8.2, while in comparison, the Chinese information is very low. It's only 4.5 and 5.0. And the general English English information content per word in the sentence is around 7 bits. So we can see the Chinglish, the non-native English, has much higher contribute than either English and Chinese. This is probably the reason why it's more difficult to understand, because it's too informative. It's not clear enough. It's informative but not clear enough. And that'll be it. So does anybody have any question?
I have a question. Does this
Sure.
only apply to writing and not speaking, or would you say that Chinese speak in a more circular manner?
Right. It should apply to both, but we don't have a spoken speech corpus for Chinese.
Well,
So if I found one, I definitely do some study on that.
Could you give an example of something that's easier for a Chinese English person to understand than an English person?
This is it's a little bit difficult to come up with, but we can sort of go back and look at this sentence. So linguistically, we could notice that Chinese words do not have plural inflections. Like 20 years ago, we don't say 20 years ago. And we don't have verb tenses. So in this one, even we are talking about the past, we still use the normal form. And the information that conveys the past tense is entirely contained in the sentence. So when Chinese speakers try to formulate an English sentence, they may drop those information, and that could cause different change in the increase or decrease information in the sentence and in the paragraph. And well, more generally, because this comparison shows even this is the effect of the global effect. This is a graph of the global effect. So in the left one shows the Beijing News Agency, the official Chinese news articles. Globally, you can see the information is decreasing. And this is also observed in the Chinese English corpus. So there must be something other than local sentence effect, but more with the writing style, how you are trying to convey your ideas things like that. And maybe next year I can show you an example.
But the whole point is it's going down.
Right.
rather than increasing.
Well, I didn't attach a graph, but in an English corpus study, it's clear that it's going up. Very clear trend. Sure.
Two questions. First, you mentioned that in the Gensel and Charniak, they used estimates both of how the words were used and which words were used.
Mm-hmm.
Did you also have those pure lexical estimates?
No. Yes, I do. Yes, I do. And they are very similar to the lexicalized part of speech ones. Dr. Yeager and I actually had a discussion on this. We think that most of the effects of Chinese writing can be already captured by words. So the syntactic information is already contained in pure word combinations. So actually the two graphs look almost identical. You would, even with the trigram model, you don't notice any difference actually.
And my second question, I guess you may have just answered it, but would you expect a different result if you also included information about the syntactic structure that the lexical item occurred in? So if you used a probabilistic context-free grammar to parse the corpus first.
Oh yeah, definitely. We are actually going to do to parse the corpus with the parser and do more syntactical level analysis. And what has been done in English corpus is that the trend is generally similar, but it's sort of more obvious and more significant. And in Chinese, I would definitely consider so. And if you know that the writing of Chinese does not reflect the sound of Chinese, it's entirely irrelevant. So, but there's also a phonetical system, phonetic like alphabet system for Chinese. So I'm converting those characters into the phonetics and do the direct analysis on the written phonetic alphabet of Chinese. It's a strange way of doing things, but that is is closer to speech and may be able to provide us a better insight on this matter. Okay, thank you.